Welcome to the first example video from section 2.4. In this one, we are going to be looking at modeling real-world situations with quadratic functions. So really what this is going to involve is you're going to be given some data, and based on that data, you're going to need to determine the quadratic function to model the situation that the data is from. So this is very similar to last chapter when you had linear equations and you were given some information, and based on that information you had to figure out which method to use to get your equation. Same here. So what you need to remember is we've got a few different ways to write our quadratic functions. The first of which is vertex form. And if you remember, vertex form is y equals a times the quantity of x minus h squared plus k. And if you remember also, h and k are the points, or the coordinates of the vertex. So hk is our vertex here. So when you are given some data that includes the vertex and another point on the graph, you can use vertex form to go ahead and find that equation. So I'm going to walk you through the steps right now. You need to make sure that you're taking notes and writing all of this down, because this is going to be the same process that you're going to do anytime you're given the vertex and one other point on your graph. So let's go ahead and look at the problem. So the graph shows the parabolic path. Parabolic, that just tells us that this is a quadratic because this shape follows a parabola. A parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. So if you think about this, remember, if someone gets shot out of a cannon, they usually make this arc type shape, or any projectile. If something is shot out or hit, it starts whatever height it's at, and it travels up and up and up until it reaches its maximum point, and then it starts coming down. That's a parabola shape, so we can use quadratics to model the height and the distance that object travels. So first thing we want to do is write an equation of the parabola. Let's focus on that first. We'll figure out the second part of the question after. So what you want to do is look at your graph, and you'll notice that you've got 2 points labeled here. One of which is the vertex. Remember, the vertex is always the maximum height or the minimum height. So here we've got our vertex, and we have one other point. This happens to be our y-intercept, but it doesn't matter. It can be any point on the graph. So we know that the human cannonball started at a height of 15 feet, because at 0 feet traveled, he's up at 15. And then he shot out, he traveled. After he's gone 50 feet horizontally, he's 35 feet in the air, and then he starts coming back down. So let's first write an equation. So since we know 2 points on this graph, we know the vertex and we know this point, we're going to use vertex form. Now, if you remember from vertex form, you should all have that written down. In vertex form, we have 3 values that we need to find. We need h, k, and a. So we don't know a yet. We're given h and k, but we're going to use this other point that we're given to solve for a so we can get our full equation. So we're going to use the vertex and this point, 0, 15, to solve for a. So the first thing that you want to do is you want to go ahead and plug in your vertex. So you're going to get y equals a times the quantity of x minus 50, right? 50 is the h value. That's the x coordinate of our vertex, squared, plus k, which is 35. Now, we almost have our full equation right here. We're almost there. The only piece that we're missing is this a value. We don't know what that is. So what we can do is, since we know our graph goes through 0, 15, we can plug in 0 for x and 15 for y, into our equation, so 0 for x and 15 for y, and that's going to give us an equation with only a as our unknown. A will be the only value we don't know, so we can solve that, and that'll help us get our equation. So let's go ahead and do that right now. So if we plug in, we've got our vertex form, we plug in 50 and 35 for h and k, and like I just said, to solve for a, we're going to plug in 15 for y and 0 for x. So now we've got this equation right here that has just a as the unknown. So this is simple. All we have to do is isolate a, and we'll get our value. So if we go here and start working through, we can go ahead and subtract 35 from both sides. So we'll get negative 20, and then 0 minus 50 is negative 50. So negative 50 squared is 2,500. So we get negative 20 equals 2,500a. All we do is divide both sides by 2,500, and we get a equals negative 0.008. So that's all the information we need for the first part. We've got our equation. So we've got h, k, and now we've got a. So we just plug those in, and we can get our equation right here. We get y equals negative 0.008 times the quantity of x minus 50 squared plus 35. And we know that because we know our a, h, and k values, and we're plugging them into vertex form. Now, we want to find the height when the distance traveled is 90. That's the second part. It says the performer lands in a net 90 feet from the cannon. So right here, we know that the total distance traveled is going to be 90. So for our equation, we're going from 0 all the way out to, at this point, this is 90 right here. So that's the domain of our range, domain of our equation. We're only going for 90 feet right here. So to find the height when x equals 90, all we need to do is plug 90 into this equation for x, and we're going to get our solution. Okay, so now this would work with any value. If we wanted to find the performer's height when the distance is 60, we would just plug 60 in for x. But in this case, we want to know specifically when x is 90, how high is the performer. So let's go ahead and plug that in. So if we plug in 90 for x, now we just go ahead and simplify. So when we get this, 90 minus 50 is 40, so we take 40 squared. Remember, order of operations with PEMDAS, you do parentheses first, so 90 minus 50, which is 40. Then you do exponents, so 40 squared, so 160, and then 160 times 1,600 times negative 0.008. So we go ahead and multiply that out, and then we add 35, and we get 22.2. So what that means is that the height of our net, so at 90 feet when the performer lands, the height is about 22 feet, so 22.2. Okay? Now, you can rewind and go back through. And remember, this works for any problem that you know the vertex and one other point. Again, your steps are to use vertex form and plug in the h and k values from your vertex and plug in the x and y values from your other point to solve for a. Once you get your a value, you plug that into your equation along with h and k. So you have your function. So y equals a times the quantity of x minus h squared plus k. You plug in a, h, and k. And then to solve for another value, you just plug in your x value. So what I want you guys to try right now is I want you to do these two questions right here. So for the first one, I want you to, how would this change? What would the height of the net be if the vertex was at 50 and 37.5? So instead of 50, 35, what if it was 50, 37.5? So I want to know what the height of the net would be if the vertex changed. Everything else still is the same. The height, the x value is still 90, so you're still trying to find the height of the net at a distance of 90, but the vertex is different. For the second problem, I want you to write the equation of the parabola that passes through these 2 points. So the point -1, 2 and has a vertex of 4, -9. On this one, I just need the equation. So again, if you have any questions, you can just rewind and rewatch the example. We cover both of these. We go over how to do that in the video. So go ahead and please answer your questions separate. Please label them 1 and 2 so I know the answers. 1 should be the height of the net. 2 should be the equation of your parabola that passes through this point and has a vertex 4, -9. Go ahead and answer those now.